Hello, welcome to another of the little videos about our MachStdMill software. In this set of videos I'm talking about the use of an optional piece of hardware called the Tool Change Position Touch Plate, which you'll find referred to in various spots inside the user manual. And what this piece of hardware does is it is essentially a sensor which creates a probe event into Mach, and then the software knows how to use that event to do various things. Probably the most common thing that we do with the Tool Change Position Touch Plate is to measure tool lengths as part of a tool change. This allows you to automatically measure their length as they're mounted and is a convenient way to run a program. Now, before you can use any of the features which use the TCP TP or the Tool Change Position Touch Plate, you must first teach the system where this plate is in physical space. So this little video is going to show you how to calibrate where that plate is. Now, what we've got here is I got the video camera set up showing my machine. I've got the spindle nose here at the top. You'll see a piece of a collet sticking out the bottom. Let's ignore that for a moment. And down here is the table, and off to the right is the vise. I happen to be at my home position. I have just referenced the machine, so I'm not over the Tool Change Position Touch Plate. And I did that on purpose because I want to show you a couple of things here before we get to the actual operation. So to calibrate the touch plate, you want to go to the Settings Common page. So this is the Settings page. We're on the Common tab. And some stuff is covered up here by the video window, but that's okay. The controls we're talking about here are right down here in the bottom right-hand corner of this upper panel. Now, the first thing that you must do is, if you're going to use the TCP TP, you have to tell the system it's there. So this button is currently on. If I turned it off, the software says, I don't have the optional hardware. I won't allow you to do any of the operations which require it. So I have turned the button on, telling the system that the hardware is installed, and now the system can use it. Now, it's very easy to calibrate it. It actually takes much longer to explain it than it does to actually do the process. But one of the requirements is that you have to start this operation from the tool change position. Well, I'm not at the tool change position right now. I'm at the machine's reference position. But I'm going to show you what happens if you try and start it when you're not at the tool change position. So I go ahead and click the button, and it says, as you would expect, I'm sorry, it's got to start from the TCP. And because I was not at the TCP, it did not continue into the special function and set the calibrated level for the plate. So let's go over to the tool change position. By far the easiest way to do that is to go to the tooling page. And of course this does require that you have a tool change position set up before you can do this calibration. But I'm just going to tell the machine to go to the tool change position. So the machine moves over, goes to the tool change position, which in my case is essentially all the way over at positive X for travel, a little bit in positive Y because I run the machine in quadrant 3, and at the top of Z travel. So I am now at my tool change position. Let me give you a caution here. Do not attempt to jog to the tool change position in order to start this process. Use the button to go to the tool change position. The precision with which the machine checks to see that you are indeed at that position at start is much more precise than you will probably ever be able to get to jogging, so don't get frustrated by trying to do it with a manual jog mode. Now, we're over the tool change position. We could run this function, but before we do, I want to talk a little bit about what we're trying to do here. So there's a couple of things to realize. There's a couple of important reference points on the machine. One is the bottom of the spindle nose here, which is the typical place that a machine will have what's called the gauge line. It is this plane at the bottom of the spindle that is used for referencing all tool measurements. So we want to pick that gauge plane, and we want to know where it is, and we don't ever want it to change. Now, fortunately, it's very hard to get it to change on most machines, and the most common place for it to be is at the bottom surface of the spindle nose. So in the case of my machine, this is the gauge line here, and it is from that point that we want to measure things. Now you may say, well, how do I know where that is? I know where it is physically on the machine. Remember that I have just referenced the machine, and the machine knows where it is in absolute machine coordinates. Now, a note about precision here. The accuracy of all these measurements does depend upon the accuracy of your home switches. If your home switches are not giving you accurate, repeatable values, then you're going to have errors that are introduced to these measurements. So it is worth taking some time to figure out how to get your home switches so that they are accurate and give repeatable results. So using this, what I really want to do is I want to bring the machine's gauge line down. I would like to bring it down and touch the plate. When it touches the plate, an event will be caused to Mach, and I will know the machine coordinates we're at, I can tell you where this plate is in physical space. Now, I can't do that process on my machine. The reason is that I don't have enough travel on the machine in Z to actually come down to touch where I have the plate mounted. Therefore, I need to put in a tool here in order to fill up some of the space so at the bottom of the tool will be able to come down and touch the plate. So this is the reason that you'll see in the dialog in a minute what the system is going to require is it says I need to know the length of a tool which is mounted in here, and I'll show you how that works in a second. If you'll bear with me, I'm going to go ahead and put in a tool that I've set up to do this with. It happens to be a chuck. I'm going to put it in the machine. I have manual wrenches on this machine for changing tools, so bear with me, it takes slightly longer than I expected. And of course you always feel like you're rushing when you're doing a video here. Okay, now what I have done is I have mounted a chuck into the machine. Now on my system I happen to have tooling so that when I mount the tooling it's referenced to the gauge line here, but I can measure the length of this assembly offline, and I do that with a surface plate and a height gauge, and I know what that length is, and now I can tell the system what this extra length is in order to calibrate the touch plate. If you do not have the ability to measure tools offline, then you have a little bit of a cart and a horse situation. Say you're using something, it doesn't matter what this tool is, but suppose it were something like a collet, which when I tightened it up, it actually changed the physical length of the tool a little bit. Well, for this calibration process, you need to know the length of the tool which is mounted that you're using for the calibration, and you need to know it accurately. If you get that number incorrect, it will introduce an error which will be carried over into all of the measurements made, because the system will then think the touch plate is at a location where it isn't really located. Now, if you have a height gauge of the right height, what you could do is you could come in here and set 0 to your gauge line. You could then move your height gauge down, measure the bottom of this. The difference of those two things would give you the length of the assembly. That's inconvenient for me to do on this machine because my height gauge is too tall and the head of the machine is large enough that the height gauge hits by the time I want to come in and measure it, so it's just much easier for me to do an offline measurement. So what I have done is I've just used the chuck. I've got the jaws all the way extended, and it was just a convenient tool I grabbed off of the tooling in order to do this process with. Okay, enough talking. Let's actually go do this. We'll go back to the settings page. We have it installed, and I'm going to tell it that I want to set the position for the touch plate. It says, do you want to do this? I say, yep. It says, okay, please tell me the length of the tool which is installed. In this case, it is 4.2257. I'm going to tell it that's the length. It says, thank you. Comes down, lowers the tool to the touch plate, which is going to cause the probe event into Mach. I have this set up for double probe, by the way. Notice this is the old position. It has touched it. It has figured out where it is, and it has set the position of the touch plate. I will say OK to exit the dialog box, and you will notice that the touch plate is positioned on my machine at minus 13.0056 in machine coordinates. Now, the number you saw here before was a different number because I had purposely done this operation before starting the video to make the number wrong so that we could see something to see how it corrects it. In any case, that is the end of the process for calibrating the touch plate. Now that the system knows where this is, you can use this for tool changes, and it can be used to measure tools on the machine. Now, one caution. If you should ever move the touch plate after you've calibrated it, realize that you will need to go back in and run this calibration procedure again, because if you move the height of the plate, that will change the number that MSM remembers, and of course that would throw your measurements off when it's being used during tool change sequences. But if you don't move the touch plate, you only need to do this once when you first set it up, and then you can pretty much forget about it. So that concludes my short little narrative about how to calibrate the tool change position touch plate. In some of the other videos I'm going to come back, we're going to talk about how to use that for tool changes, how to do automatic tool measurements, and in particular how to use master tool mode with only non-repeatable height holders as an example to dynamically measure tools as you mount them, and in conjunction with using a probe to make setup easy. So we'll use some of the advanced options in the videos that depend upon measuring tools. Thanks a lot, and hopefully you'll see another one of our videos shortly with more information about this. Thanks.